You know the feeling. You type a question into a search bar, hit enter, and boom. In less than a second, answers from all over the planet are right there on your screen. We do it all day, every day, and it feels completely, totally effortless.
Right? It's like all the complexity, all the distance just vanishes. Information just appears, and we have a name for it, the cloud. It's a word that makes you think of something weightless and automatic and just kind of up there. But here's the thing. That's a myth. I mean, what really happens? What incredible chain of events, what combination of people and machines actually kicks into gear the moment you click that button? Well, today, we're going to peel back the layers and see the very real, very physical, and very human system that makes it all work. So, first things first, let's talk about the people. There's this idea that a search engine is just this pure, automated computer brain. But the truth is, every single search you make is tangled up with a whole lot of human labor.
This chart breaks down the hidden workforce. Yeah, you've got the highly paid engineers at the top, the ones we see. But underneath them, there are armies of quality raters who are literally sitting there manually checking search results, often for as little as $13 an hour with zero benefits. And at the very bottom, guess who? That's us. Every single time we search, we are providing free labor, constantly giving feedback that tunes the very algorithms we're using.
And this isn't just a Google thing. Jeff Bezos laid it out perfectly when he announced Amazon's Mechanical Turk service. This is the model for the whole digital economy. Human thought itself is treated like a computer resource, a service that can be called up with a line of code, totally hiding the real person doing the work. Okay, so if the internet is run by people, where exactly are all these people and all these machines? This is where that whole cloud metaphor really starts to fall apart.
On the left, that's the myth, right? The fluffy little icon we see everywhere. But on the right, that's the reality. The internet lives in these enormous, very physical buildings called data centers. They're just giant warehouses packed to the gills with computer servers, burning incredible amounts of electricity to keep everything running and cool. They are 100% on the ground.
And because they're physical places, they're vulnerable. Nothing made this more obvious than Hurricane Sandy back in 2012. When that storm slammed into lower Manhattan, it didn't just flood the streets, it came dangerously close to knocking huge pieces of the internet offline. Just look at what happened at the Pier 1 data center. The power for the whole city goes out. No problem, they've got backup generators on the roof. But the fuel pumps for those generators are in the basement, which is now completely flooded. The only solution? A human bucket brigade. For days, workers and volunteers literally carried buckets of diesel fuel up 17 flights of stairs around the clock just to keep the servers running. This is the kind of invisible care work that our digital world actually depends on. Now, a story like that makes the internet sound unbelievably fragile, right? So how on earth can a system with such glaring weak spots be so incredibly resilient at the same time? Well, the answer is baked right into its core design.
For the original architects of the internet, the #1 goal wasn't speed or efficiency or anything like that. It was one simple, brutal idea: survivability. The whole network had to be designed to keep working even if huge chunks of it were, well, literally blown up.
And the secret sauce to making that happen is this really clever principle called fate sharing. Here's the idea. Instead of making the network switches in the middle smart, you make them as dumb as possible. All the important information about a connection is held by the two computers at either end of the conversation. So if a switch in the middle gets destroyed, who cares? The conversation doesn't die because its fate is shared by the endpoints, which is still alive and can just find another route. But why? Why this incredible obsession with survivability? I mean, this wasn't about planning for hurricanes. The real reason the internet was built this way goes back to a much, much bigger threat. This whole design philosophy is a direct product of the Cold War. The US military was terrified that a Soviet nuclear strike could wipe out its command and control simply by targeting the few central hubs of the old telephone system. They needed a new network, one with no single point of failure.
And this slide shows you exactly why. A centralized network is like a spider web. Take out the center, and the whole thing is useless. A decentralized network is a little better, but you still have major hubs that are obvious targets. The solution had to be a distributed network. Think of it like a fishnet. It has no center at all. If you tear a few holes in it, messages can just find a path around the damage.
And the technology that made this fishnet design possible is called packet switching. Instead of needing one continuous connection, like a phone call, your message, an email, a picture, whatever, gets chopped up into tiny little blocks called packets. Each one gets stamped with a to and from address, and then it's just tossed into the network to find its own way there.
Paul Baran, one of the guys who came up with this, had the perfect analogy for it. He called it hot potato routing. Every node in the network treats each packet like a hot potato. It doesn't analyze it, it doesn't hold on to it, it just figures out the fastest way to pass it along and gets rid of it. That simple, dynamic rule is what lets the entire network react to damage in real time.
Okay, so let's pull all of these pieces together. We've journeyed from this myth of a magical cloud to reality that's a whole lot messier, and honestly, a lot more amazing.
So what have we found? The internet isn't magic. It's powered by a hidden hierarchy of human work. It's not a cloud, it's a physical collection of very real buildings. And its amazing resilience isn't some happy accident. It was a deliberate choice designed from the ground up to survive a nuclear war.
So if the cloud is the wrong metaphor, what's a better one? Maybe we should think of the internet as a city. It has physical infrastructure, it's built on a specific blueprint, and it needs constant, 24/7 maintenance, care, and labor from millions of people just to keep the lights on. When you realize the internet isn't magic, but this monumental, ongoing human achievement, it kind of changes your relationship to it, doesn't it? It means we're not just users. We're residents of this city. And our actions, our clicks, our data, our labor, are the very bricks and mortar that build and shape this place every single day. So the real question becomes, what kind of city do we want to build?